teacher of chemistry. Welcome to STV, Select and Learn program. I'm here to teach organic chemistry, and basically today we are going to look at what we call organic compounds, basically hydrocarbons. So we're looking at hydrocarbons. We are looking at hydrocarbons. Hydrocarbons. Before we start our discussion, organic chemistry has mainly 4 pillars. These pillars include nomenclature. They include nomenclature. And nomenclature simply means naming of organic compounds. Pillar number 2 is what we call synthesis. And synthesis basically means how to form compounds using given reagents under specific conditions. Then 3, we have what we call mechanism. Mechanisms. And mechanisms are steps involved during a chemical reaction. Then 4, we have a concept known as distinguishing. And identification. Distinguishing and identification. Distinguishing and identification simply we look at how can we use different reagents to identify the organic compound provided to us, and how can we use those reagents to distinguish this organic compound from the rest. So back to our hydrocarbons. What are hydrocarbons? Hydrocarbons simply mean organic compounds that consist of carbon and hydrogen only. So they contain carbon and hydrogen. But now, the hydrocarbons have mainly 3 classes. We have the alkanes. We have the alkanes. And we have the alkynes. The alkanes and alkynes react differently. However, there are some reactions that are involved by all. For example, if I look at combustion, combustion simply means burning of substances in air. So, when hydrocarbons burn in air and all other organic compounds, they form water and carbon dioxide. For example, if I choose my hydrocarbon CXHY and I react this with oxygen, I'll form carbon dioxide and water. So all hydrocarbons burn in oxygen to produce carbon dioxide and water. But now, during combustion, the number of moles produced by carbon dioxide are specific, and we term them as a X. And those that are produced, I mean amount of water, is Y out of 2. So we are forming X carbon dioxide and Y out of 2 water. The Y out of 2 means number of moles of water that are produced during combustion of a hydrocarbon. Now, the question is, how can we know the number of moles or the amount of oxygen that has reacted with the hydrocarbon? We can simply balance this equation by looking for, if I can say number of moles, let the number of moles of what? Of oxygen, number of moles of oxygen, let the number of moles of oxygen, let the number of moles, number of moles of oxygen be K. So an equation is like an equal sign. You are looking at this part and the other part. I'm trying to look for the balancing figure of oxygen. So if the number of moles of oxygen is K, so I'll put K there. So that means the number of oxygen this side are equivalent to the number of oxygen this side. So that means my K will equal to, I have 2 oxygen atoms, 2x plus Y out of 2. So if I look this side, also oxygen has a 2. So I'll be having 2K. So if I'm looking for the value of K, I'll simply divide through by 2. So I'll be having 2x plus Y out of 2. I divided by 2. So I'll end up getting 4x plus Y out of 4. So this makes the number of moles of oxygen that reacts with a hydrocarbon. So I simply balance it by, I simply balance my equation by putting 4x plus Y out of 4. So this is the general equation for conversion of all hydrocarbons. But remember, we said there are basically 3 classes of hydrocarbons. You have the alkanes, alkenes, and alkynes. So if I start by looking at alkanes, alkanes. First of all, I need to know what are alkanes. What are alkanes? Definition. Alkanes, first of all, are hydrocarbons, as we have said, but these hydrocarbons are saturated and they have a general formula of CnH2n plus 2, where N means number of carbon atoms. Number of carbon atoms present in that compound. So we are saying alkanes are saturated, they are saturated organic compounds. Saturated organic compounds, or you can simply say hydrocarbons. can simply say hydrocarbons. Hydrocarbons. But what is the meaning of saturated? In simple terms, you can say saturated means they have enough. In other words, the carbon atom in alkanes, remember if you go back, we try to go back, we know carbon atomic number is 6. So it is 2 to 4, basing on our O-level knowledge. Okay? So that means carbon has a valence of 4. So the outermost shell of carbon has 4 electrons. And these 4 electrons are ready and available to be contributed or shared during bonding. So by saying saturated, we simply mean the carbon atom in alkanes uses all the 4 valence electrons to bond with other atoms. For example, if you just give an example of methane. Methane is CH4. So you find that in methane, carbon bonds with hydrogen using all its 4 valence electrons. So in other words, in this compound, the alkane, the carbon atoms are surrounded by 4 bonds. 1, 2, 3, 4. They are surrounded by 4 bonds. So they are saturated. And what makes them to be saturated, we have said, the carbon atom uses all its 4 valence electrons to bond with others, sharing with others. Again, in alkanes, we shall find that alkanes are less reactive. And what makes them to be less reactive is what I'm talking about right now. That they are saturated and they use all their 4 valence electrons to bond with others. And now they form short bonds because the carbon and hydrogen almost have the same electronegativity value. So breaking the carbon-hydrogen bond requires some amount of energy. So it is not easy to break this bond. Hence, the alkanes are less reactive. Now, we say in the pillars of organic chemistry we have nomenclature, we have synthesis, mechanism, distinguishing and identification. The question is, how do we name alkanes? How do we name alkanes? How do we name alkanes? Naming alkanes. Naming alkanes. Naming alkanes. So alkanes, as the name sounds, we are looking at alkanes. Alkanes. We are looking at these last 3 letters, A, N, E. So alkanes are named by ending with A, N, E. Basing on the number of carbon atoms, we have different examples of organic compounds. For example, a compound that contains 1 carbon atom is known as methane. Is known as methane. And that one that contains 2 carbon atoms is known as ethane. And an alkane with 3 carbon atoms is known as propane. And that with 4 is known as butane. 5, it is pentane. pentane. And after 5, we use the knowledge of polygons. Hexane, octagon, nonane, the polygons we did at primary. So the carbon atom, the number of carbon atoms give us the name or give us the structure of the organic compound we are talking about in terms of alkanes. Methane, ethane, propane, butane, and pentane. But now, after naming, we need to know the structure. We need to know the structure. We are saying methane has only one carbon atom. But remember, we said the carbon atoms must be surrounded by 4 bonds. So if I'm looking at methane, it has one carbon atom, meaning it is going to be surrounded by 4 bonds. By 4 bonds. And these 4 bonds, because we are talking about hydrocarbons, those bonds, they are attached to hydrogen. Because we said hydrocarbons are organic compounds that consist of carbon and hydrogen. So I'll put here my carbon atom, hydrogen, and hydrogen. So this is the structure of methane. But I can put it a condensed structure. I count the number of hydrogens I have. I have 1 carbon atom and how many hydrogens? 1, 2, 3, and 4. So I put CH4. So this one becomes a condensed structure of methane. Let me look at ethane. Ethane has 2 carbon atoms. That means in ethane, 1 carbon atom is bonded to the other. I have 1 carbon atom bonded to the other. That means both the carbon atoms have contributed one of their electrons to coordinate with the other. To coordinate with the other. So now, if I'm trying to put the number of bonds around each carbon atom, I start with 1. Now everyone can see that it is missing only 3 bonds. 1, 2, 3. Even this one, 1, 2, and 3. But we are dealing with hydrocarbons. So that means here I'll be having hydrogen, 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 hydrogen. So if I condense this structure, I come up with C123, CH3, CH3, and also have 1, 2, 3, CH3. So the structure of methane, the structure of ethane becomes CH3, CH3. Or you can leave it like this, but this one consumes space if you are using your book. So it is better we use the condensed structure because they are easy to manipulate even during mechanisms, synthesis, and during exams. Now, if you look at propane, I guess now we can. Propane has 3 carbon atoms. But remember, in alkanes, the elements or the atoms are connected by single bonds. You shouldn't forget that. So that means if I have 3 carbon atoms, the 3 carbon atoms are connected to each other by a single bond. So now, the carbon atom has to be surrounded by 4 bonds. Each carbon atom, for example, the first one, has only 1 bond. So it is lacking 3 bonds. The middle carbon atom is already connected to 2 bonds. So it is lacking only 2 bonds. The terminal or the last carbon atom is connected to only 1 bond. So it is missing 3 bonds. But remember, these are hydrocarbons. So this carbon atom, I'm connecting it to hydrogen, 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 hydrogen. So if I condense this structure, I'll be having CH3, CH3, then CH2, then CH3. So this one becomes my propane. It is a hydrocarbon one. The atoms are connected by single bonds. Carbon, carbon, single bond. And secondly, the carbon atoms in it are saturated. Each carbon atom is surrounded by 4 bonds, meaning it uses its 4 valence electrons to bond with others. Now, that is pillar number 1, that is nomenclature. But we said pillar number 2 is synthesis. Synthesis. Or we can call it preparation. Preparation of alkanes. Preparation of alkanes. Basically at this level, we shall look at laboratory preparation of alkanes. There are some industrial preparations, but under industrial preparations, the conditions cannot be afforded using the labs we use at school. So we're looking at preparation of alkanes, basically laboratory preparations. How can we prepare alkanes? First of all, in preparations, we need reagents or chemicals. Reagents. And we also need specific conditions. Specific conditions. Conditions. We need reagents and need specific conditions. Conditions can be in terms of temperature. At what temperature? Because chemical reactions take place at specific temperatures. We can look at concentration of the reagents, concentration, and solvents. Some reactions require specific solvents to take place. So now, if I start by preparation, alkanes can be prepared. Alkanes can be prepared, first of all, by hydrogenation of alkenes. They can be prepared, 1, by hydrogenation. Addition of hydrogen onto alkenes. So simply hydrogen is reacting with alkenes. Hydrogenation of alkenes and alkynes. Alkenes and alkynes. So by hydrogenation, we are simply meaning addition of hydrogen. Addition of hydrogen. Addition of hydrogen. And addition of hydrogen, for this case, it is a slow reaction. It needs some metal catalysts and a specific temperature. So the addition of hydrogen requires some metal catalysts. Catalysts. We know what catalysts are. Catalysts are chemical substances that speed up the rate of reaction. So metal catalysts, for example, nickel catalyst, nickel catalyst, nickel catalyst. We have platinum, platinum. We have platinum, platinum. We have palladium. We have palladium. Platinum, the symbol is P. P capital T small t, and that of palladium is capital P small d. Now, when we use nickel catalyst, the reaction takes place at 150 to 200 degrees Celsius. But be specific. You choose one temperature, either 150 or 200 degrees Celsius. And the platinum and palladium, they all work at a room temperature. They work at room temperature. So we are saying method one of preparing alkanes is hydrogenation of alkanes and alkynes. I'm saying this one simply means addition of hydrogen onto alkenes and alkynes. But because this reaction is slow, we need some metal catalysts. For example, nickel catalyst, platinum, and palladium. So now, if we give some examples, if you try to give some examples, if I want to prepare, let me give an example of ethane. If I want to prepare ethane, we said it's simply CH3CH3 propane. Now, I need to know the number of carbon atoms present in this compound. There are 2 carbon atoms. So, if I want to prepare ethane, I need an alkane or an alkyne with 2 carbon atoms, and on which I can add my hydrogen to get ethane. For example, if I want to prepare ethane by hydrogenation, I need ethane. Ethane is double bonds. Alkenes, the functional group is a double bonds. So this is the structure of ethane. This is the structure of ethane. So if I'm going to form ethane, I need ethane, and I add hydrogen onto ethane to get ethane. So now I'll be having my ethane, and I add hydrogen on my ethane, then we say this reaction takes place in presence of a metal catalyst. For example, if I use nickel catalyst, I need a temperature of 150 or 200 degrees Celsius. Ethane, I'm adding hydrogen. But the hydrogen molecule contains 2 hydrogen atoms. That means these 2 hydrogen atoms are going to distribute themselves between the 2 carbon atoms that are having the double bonds. So I'll end up getting my ethane. So I'm adding hydrogen. By hydrogenation, I'm breaking the double bonds. I'm converting this unsaturated organic compound, an alkane, by adding hydrogen. Okay, then I'm getting ethane, which is an alkane. This method. The reaction is slow, so don't forget metal catalysts. Nickel catalysts at this temperature, because always the marks will go for that. And proper structure of the product, conditions, and the product. Now, we say there is also another concept, and that concept, we call it mechanism. steps involved during a chemical reaction. Remember, I was preparing ethane from ethene by hydrogenation. By hydrogenation. So plus hydrogen, I get nickel catalyst at 150 degrees Celsius. I end up forming my ethane. But now I need to know the reaction pathway or the mechanism. How do I form my product? Steps taken during a chemical reaction. Now, alkenes have double bonds. Alkenes have double bonds. But the bonds mean electrons. So alkenes are electron rich. Because for me to form a bond, we either share or isolate electrons. For example, this is covalent bonding or covalent bond. We share electrons. This carbon atom and this carbon atom share electrons. So these bonds here, each bond consists of 2 electrons that have been contributed by each carbon atom. And because the alkenes have a double bond, they are electron rich. And electron rich species are known as nucleophiles. Electron rich chemical species are known as nucleophile. Then the electron deficient, or those ones that have less electrons, the opposite is electrophiles. So always nucleophiles attack or react with electrophiles. Nucleophiles always attack electrophiles. For example, now if I have my ethane, we said ethane has double bonds, and because the bonds are formed due to sharing of electrons, the alkenes are electron rich. So they are nucleophiles. Now if I look at the hydrogen, because ethane is reacting with hydrogen molecule. The hydrogen molecule, I can simply put it like this. So now what happens? We take an assumption that the 2 hydrogen atoms have different electronegativity value. By electronegativity, I simply mean the tendency of an atom to withdraw bonding electrons towards itself. Okay, let's go for a short break. We shall be right back.
Schools have been shut down for 32 days due to coronavirus pandemic. To keep your kids safe and educated, you don't have to get into your pockets. STV brings teachers to your living room. Select and learn with STV.